Alright, let's look at this question on trigo. We are given this figure where B, C, D and E all lie on a circle with center O. Okay, EC is the diameter of the circle, angle DBC is 39 degrees, and ODB is 12 degrees. Find the following and give appropriate reasons. Okay, so the first thing that we are asked to find is angle DEC. Okay, so angle DEC, where is DEC? DEC over here. Okay, so we need to apply some of the rules of angles within circles. Okay, triangles and circles, those rules that we have. So we know that both that D and C is a common line here, which means that with D and C being a common line, when I draw a third point up that touches the circumference like this, all of these triangles are considered to be in the same segment, and all the angles in the same segment are equal. Okay, which means the angle DEC is equivalent to angle DBC, which is equals to 39 degrees. Okay, so the rule we are using is angles in the same segment. Okay, so that is the first part here. Now let's look at the second part here, angle DOC. So angle DOC. So to find this, you must apply the rule that says that angle at center, okay, is equals to 2 times the angle at circumference. Okay, so again, D and C is the common point here. So from D and C, we are drawing two triangles, one that touches the circumference and one that touches the center. So we can apply this rule. So we can say that angle DOC is equals to 2 times 39 degrees, which is equals to 78. Okay, so that is the rule we have applied. Okay, so let's go on to part 3 over here. Okay, so in part 3, what are we supposed to find? BDC, and hence the special name given to triangle BCD. Okay, so we're supposed to find B, D, and C. Okay, so we know that this angle here is 39 degrees. Okay, and with this angle being 39 and EOC being the diameter, okay, when you have a line which is a diameter, and from the diameter we draw a third point that touches the circumference of the circle, that is the angle in a semicircle, which is always 90 degrees. Okay, so you know that this angle here, angle EDC is equals to 90 degrees. So based on that, we can say that angle BDC is equals to 90. Okay, so before that, we still need to find what is this angle over here. Okay, so this angle, how do we find? We know that this is the center of the circle, which means that OE and OD are both radius of the circle. Okay, and since both these sides are radius, they are equal, that makes this triangle OED an isosceles triangle. So this is 39 means this is also 39. Okay, so that solves our angle there. So ultimately, angle BDC is equals to 90 minus 39 minus 12, which is equals to 39 degrees. Okay, so if this is 39 degrees and DBC is also 39 degrees, which means that this, okay, triangle BCD is also isosceles. Okay, it's also an isosceles triangle. Okay, now let's go on to part 4 over here. So in part 4, what are we asked to find? We are asked to find angle BED. Okay, so let me erase some of this first. Okay, so angle BED. Okay, so in a circle, when you have a quadrilateral, we know the opposite sides of the quadrilateral add up to 180 degrees. Okay, so if I know BCD, I can find BED. How am I going to find BCD? I know that BCD is isosceles. So if this is 39, this is also 39. Alright, so in that case, angle BCD is equals to 180 minus 39 minus 39, which is equals to 102 degrees. And we know that angle BED plus angle BCD is equals to 180 degrees. So angle BED is equals to 180 minus 102, which is equals to 78 degrees. Okay, so this is 78 degrees. And now we are given one more task here. Given that BXD is greater than angle BED, state whether point X is in the circle, on the circumference, or outside the circle. Okay, so we're talking about another point here, X. Okay, so let's assume that X is somewhere on the circumference here. And I draw this line here. Okay, BXD. What do you see here? You will see that BED and BXD have the same common base points P and D. So similar to earlier, where we say that these are two angles in the same segment. So if X was on the circle circumference, then X would also be 78 degrees. Okay, so X cannot be on the circumference. Alright, so we know that is not the answer. Now, the only other options, or the other two other options, are inside the circle or outside the circle. Okay, so let's assume, okay, so let me remove this first, and let's assume that X is somewhere here, outside the circle. Okay, if X is outside the circle, okay, you can see that the angle, okay, X is going to be further away from E. Okay, so when X is going to be further away from E, okay, that means that eventually this point here, okay, this angle is going to get smaller and smaller compared to this E over here. Okay, so if X is inside the circle, or sorry, X is outside the circle, then this angle here is going to be smaller, okay, than E. But if X was inside the circle, okay, then you can see that as I get closer and closer, okay, to B and D, this angle opens up even more. Okay, so the only way for angle BXD to be greater than angle BED is if X is inside, is in the circle. Okay, so it is not on the circumference, it's not outside, it is in the circle. Okay, so that is the answer for part 4. Okay, so let's go on to the last part here, part 5. Show that triangle BCE is congruent to triangle DCE. Okay, so to show congruence, there are a few things you can do. Okay, so let's move all this first. So the first thing you can see is there's a common side here called CE. So CE is a common side. Okay, and what else do you see? You see that for both these triangles, BCD being isosceles, which means that this side and this side are also the same. So BC equals to CD, correct? Sorry, BC equals to CD. Okay, because it's isosceles triangle. And finally, since EC is a diameter, both these angles, angle B and angle D, are the same at 90 degrees. Okay, so you have another common angle. Okay, where you say angle CBE is equals to angle CDE, which is equals to 90 degrees. Okay, so by the congruent rule, one of it which says side angle, okay, we can say that both of them are congruent. Okay, so we have proven that. Okay, so I hope this question has given you a good preview of how we can use some of the rules related to trigo and triangles within circles to help you solve such questions. Okay, good, thank you.